the discovery that shrunk reality. At first, it sounded impossible. The universe was not continuous. Reality had a smaller scale. This idea matters today because it quietly dismantled the belief that nature could be divided forever. For centuries, people assumed that if you zoomed in far enough, you would always find something smaller. Matter seemed endlessly divisible. Space appeared smooth. Change felt continuous. But physics was about to reveal a hard limit. The first hints came from energy behaving strangely at small scales. Light refused to radiate smoothly. Instead, it arrived in packets, discrete bursts that could not be subdivided. This was not a measurement error. It was a rule. Energy came in chunks. This discovery forced an uncomfortable conclusion. If energy was quantized, then interactions were not infinitely fine. There was a smallest meaningful unit of action. Below it, the universe stopped making sense in classical terms. As this idea spread, it began to shrink reality itself. Not physically, but conceptually, the smooth world of intuition fractured into steps. Transitions replaced flows. Possibility became pixelated. What once looked like an endless gradient now had edges, and those edges marked the boundary between what could exist and what could not. At first, this quantized picture felt limited to light, a strange quirk, not a universal rule. But as experiments expanded, the pattern repeated. Atoms absorbed energy in fixed amounts. Electrons occupied specific levels. Transitions happened suddenly, not gradually. The universe was revealing a preference. It did not allow smooth sliding between states. It enforced steps, jumps, discrete changes that could not be softened or averaged away. This contradicted everything intuition suggested. Motion felt continuous. Change felt fluid. Yet beneath perception, reality moved in increments. The world was not analog. It was granular. This realization created tension with classical physics. Equations built on smooth curves failed at small scales. Predictions broke down. Something fundamental was missing. A new framework was required. As theories evolved, the implications deepened. Space itself might not be continuous. Time might have a smallest unit. Reality could be built from indivisible pieces, stitched together by probabilities rather than certainty. This did not make the universe simpler. It made it stranger. Smoothness became an illusion created by scale. Zoom out far enough, and steps blur into flow. Zoom in close enough, and continuity vanishes. The discovery was not just about small things. It was about limits, about where explanation ends and rules take over. Reality had a resolution, and it was far lower than anyone expected. The conflict reached its peak when physicists realized what this granularity implied for certainty itself. If reality moved in steps, then prediction could no longer be exact. At small scales, outcomes became probabilistic, not because of ignorance, but because the universe refused to commit until interaction occurred. This shattered a long-held belief that with enough information, the future could be calculated perfectly. Instead, nature offered limits. You could know position or momentum, but not both with absolute precision. Measurement itself altered what was being measured. This buildup revealed a universe that was not merely small, but undecided. Particles existed as possibilities until observed. Paths overlapped. States interfered. Reality behaved less like a machine and more like a cloud of chances. Emotionally, this was destabilizing. It suggested that uncertainty was not a flaw of human knowledge. It was a feature of the universe. Even in principle, some questions had no definite answers. Yet experiments confirmed it relentlessly. Interference patterns appeared where particles should not overlap. Outcomes changed depending on observation. The universe was enforcing its granularity with mathematical precision. By this point, reality no longer felt continuous or deterministic. It felt compressed, shrunk into discrete moments and options. The smooth world of experience was revealed as an average, not a foundation. And the closer physics looked, the more reality resisted being pinned down. The climax of this discovery is a quiet but radical shift. Reality did not shrink in size. It shrank in certainty. Once quantization was accepted, the universe could no longer be described as a perfectly predictable machine. It became a system of probabilities, constrained by fixed steps and hard limits. Precision had boundaries. Determinism fractured. This understanding reshaped technology and thought. It enabled semiconductors, lasers, and modern computing. It explained why matter is stable, why atoms do not collapse, and why chemistry works at all. The shrunken scale of reality became the foundation of the modern world. More deeply, it altered perspective. The universe is not infinitely divisible. There's a smaller scale where rules replace intuition. Beneath that, questions stop having classical answers. The discovery that shrunk reality was not about making the universe smaller. It was about revealing its resolution. And that resolution defines everything we can build, measure, and understand. Sometimes the smallest shift in perspective becomes the beginning of a new future.